Hello. Sorry I can't be with you there today. I'm at an IXL conference. Actually, probably as we speak, I'm probably pulling into the parking lot of the O'Hare Courtyard and getting ready to indulge in some IXL activities, learning how to help y'all better when I get back. So, gonna miss you guys today. Appreciate the effort that you're gonna put into this video lesson. It is gonna be a little bit different. I was kind of hoping to experiment a little bit and kind of get you out of the routine. Hopefully that works for you and gives you hopefully a better opportunity to look at, especially a lesson that's going to be pretty abstract. Toward the end of the lessons of this chapter, we're really digging at parts of your brain that maybe haven't been accessed before. So hopefully, if it is a bit of a struggle, that's a good sign. Actually, it means that we're trying to access parts of your brain that maybe you don't use normally, especially in a math situation. And it's good. It's good to learn. It's good to stretch yourself a little bit. It's good to grow. And hopefully this particular lesson, I was anticipating spending 3 days on it anyway. So the fact that I'm not going to be here today, and then you have park testing the next couple days, or the next 3 days actually. So we're actually going to be able to have quite a bit of review time before our assessment. Don't even worry about the assessment right now. It's going to be next week. Won't even pick a day right now because there's really no sense in that. But at any rate, without boring you with stories, of course, let's go ahead and get started. So this is area and perimeter of similar figures. You have a packet that actually looks like your book. So I don't know which is easier for you. I figured that if you don't have your book, or you lost your book, or maybe you forgot your book today, you have the packet anyway. If you would rather use your book because it looks more like this, that's perfectly fine. We're on page 569 in the book, or the front page of the packet. So we're going to actually kind of do a bit of skipping around. The idea here again is keeping with the idea of our essential question, determining congruence and similarity. Our goal for today is to be able to see the effect that scale factor has on perimeter and then on area. So you might recall I said a few times before, if you change the dimensions of a shape, it's going to affect the perimeter. It's also going to affect the area. And I think one of the, if I can use this, one of the examples I gave was something like a triangle. So if I draw a triangle, it's not going to be perfect. Wow, that's really bad. You get the idea. It's supposed to be a triangle. This is not an easy pen to use. So I have two triangles. Yuck. There. Straighten that out. So let's say that this triangle is like 8 by 4, and this triangle is let's go 8 on this side, and we'll go 16 on this side. So clearly not drawn to scale because I don't market myself as an artist. But let's start with perimeter. Or actually, no. Here we'll go back and talk about what I explained to you before. So the rectangle's area is length times width, which means if I multiply 8 times 4, I should get an area of 32 square units. If I'm not talking about any inches or centimeters or anything in particular. Likewise, 8 times 16 to find the area of this rectangle. If I'm not mistaken, 48 and 80 gives you 128. So by looking at what happens here, I can tell that if I were to divide these areas, if I did 128 divided by 32, I can do that in my head. I don't know if you can. Not a big deal if you can or not. 128, however, divided by 32 should give you 4. And the reason being is so what that means is this rectangle's area is 4 times bigger than this rectangle's area. That's what we just calculated. So what that means is, and we kind of talked about it, the side lengths are doubled, right? This short side is twice as long over here, and this long side is twice as long over here, which means if I double the side lengths, it's actually going to increase the area times 4. I believe we looked at a couple examples of that before, so hopefully it's not too confusing. That's sort of a basis that we're going to use to be able to look at the problems going forward. So keep that in mind as we venture ahead. Have you ever played Foursquare? I never did. I saw the courts and stuff drawn outside, and I never once played Foursquare. This actually looks like it's a bootleg picture from somebody playing dodgeball. I don't think this is not a Foursquare picture because, they're talking about Foursquare. Foursquare is a game where four people stand on a court. You break this thing into four pieces, and you basically try to bounce the ball into one of the four areas and score points. It's basically a one-on-one game. Four people playing, each man for himself, so to speak. And this does not look like that. This looks like this girl is about to chuck this ball at somebody else on the other side of a dodgeball court. So you can't fool us, book. At any rate, here's a square, and according to the directions here, it says Foursquare is a ball game played on a hard surface. I don't care. This chick's throwing a dodgeball. At any rate, the court is a 16-foot by 16-foot square divided into four equal squares. So that means this distance, which we'll call the length, is 16 feet. That's not a 1. That's like an apostrophe. It means feet. This is 16 feet. There we go. More diagonal. So 16 feet by 16 feet court. All right, it's a square, and it says divided into four equal squares. So we'll follow the directions along below. Use the figure to draw a four-square court. Divide each side in half. Draw a line to divide the court into four equal squares. Okay, so let's go ahead and do that. So we're going to, as close to the middle as possible. Doesn't have to be perfect. I've seen some of your artwork. You guys aren't artists either. Haha, very funny. So there you go. So there's your 1, 2, 3, 4 equal pieces, right? And so here's what we've got. Is each smaller square similar or congruent to the larger square? Explain. All right, so here's the deal. Square, 16 by 16. If I divide this into four pieces, okay, and I basically cut this side in half, which means this side should be 8 and this side should be 8. Basically, you've got all of these squares are 8 by 8, right? And simply by default, because the big square is 16 by 16 and the small square is 8 by 8, if I was reducing the big square to one of the small squares, I would be reducing it by a scale factor of 1/2. So clearly, they're congruent. I'm sorry, not congruent. They're similar. The four squares, each of the little four squares is congruent to each other. The small part, of 1/4 of the whole big thing compared to the big square is similar. So what are they asking? Is each smaller square similar or congruent to the larger square? Explain. So it's similar. Let's see what the book says. Similar because, yeah, so the length of each side, the smaller square is half the length of each side. So basically what I explained, the smaller squares are similar to the larger square. I'll give you a second. You don't have to copy it word for word. Please don't. Please don't copy it word for word. Just understand that the main idea here is that the squares are similar. I'll give you a second to do that. When you're ready, go ahead and pause the video now to finish writing, and then when you're ready, unpause it to continue. Okay, next part. So I kind of read through this a little bit, and as it happens oftentimes, the book really confuses me sometimes, so I can only imagine how much it confuses students. It says, what is the perimeter of the larger square drawn above and the smaller square? And then it gives in centimeters. But we just said that the thing was in feet. So what I think they wanted to do, because they don't give you any directions here, is maybe they wanted you to measure this with a centimeter ruler, I should say, but like that's kind of silly. So why don't we just use the feet dimensions that are already there? So again, this is a 16 by 16 foot square. So let's go ahead and just calculate the perimeter based on that. So again, perimeter of a square, a couple different ways to look at it. P equals, obviously you can add the sides, so it would be 16 plus 16 plus 16 plus 16, or because it's a square, specifically the perimeter formula is 4s, where s is the length of a side. All right, so that's going to be 4 times 16. And believe me, this is really difficult to write. And that's going to give me 84 feet. Okay, sorry, 64. 64? 84. 6 times 4 is 24 plus 40. 64 feet. Because 16 plus 16 is 32, and 32 times 2 is 64. So this is 64. Sorry, it's late. 64 square feet. Okay, so I'm going to go ahead and put that over here. Oh no, it's not square feet, it's perimeter, so it's regular feet. I've already confused you, haven't I? Relax. Perimeter is regular feet because it's only one dimension. And what I mean by one dimension is you're only measuring a distance. So if I started here, right, so it'd be 16, and 16 is 32, and 16 is 48, and 16 is 64. So I only measured straight lines. I did not measure area. I only measured the way around. So that's 64 regular feet of perimeter. The smaller square, okay, so the smaller square is 8 by 8, which means, same formula, different value. And that value would be 8 instead of 16. So for the smaller square, it would be 4 times 8 equals 32. And that would be the perimeter of the smaller square, 32 regular feet. Okay, I apologize. If that didn't make sense, pause the video now and go back. But regardless of the mistakes that I made, we got 64 feet, make sure you cross out centimeters and put feet there, and 32 feet for the smaller square, cross out centimeters and put feet there. That'll make much more sense going along. So it says, for number 3, how is the perimeter of one of the smaller squares, 32, related to the perimeter of the larger square, 64, and the scale factor? So 32 is half of 64, correct? And we already got done explaining that, if I go back up here, without all the rigmarole, that the smaller square is half the length, right? 8 is half of 16. And now you've seen, let me turn this off, that 32 is half of 64. So basically, ignore all the red above question 3. But what this says is the perimeter of the original square, it is the perimeter, okay, sorry, forget that. So how is the perimeter of one of the smaller squares, doggone you book, related to the perimeter of the larger square? Okay, so the perimeter of the larger square should be twice the perimeter of the smaller. And how is that related to the scale factor? Well, it depends on which we are calling the original and which we are calling the dilation in this case. So we started with the big square, and then we cut it into 4 pieces. So the smaller square would be the dilation, which means dilation over original equals 1 over 2. It would be a half. So the perimeter of the smaller square is half, which makes the scale factor a half. How is the perimeter related? The perimeter, I'm sorry if you can't read cursive, perimeter is half, and also the scale factor. So perimeter is a half, semicolon, scale factor, okay, is also a half. And sorry, I had a brain fart there. I was trying to remember which letter we used for scale factor. It is indeed the letter K. So K is also a half. So you notice that when you cut the side lengths in half, the perimeter is also cut in half. Let me say that again. When you cut the side lengths in half, the perimeter is also cut in half. That's the relationship between scale factor and perimeter. Scale factor and perimeter should be the same. So take a good long look at it right now. Scale factor and perimeter right now are both half. Okay, that's the main idea in the first part of the lesson that we want to talk about. All right. If you had any issues with that, I know I spoke a little bit fast. I'm a little bit wily right now because it's midnight. I don't know if it's you can see my clock on my computer screen, but it is midnight. It was a busy weekend, and before I was like, all right, sweet, I get to go to bed. Oh wait, I didn't record a video for tomorrow's lesson, so I apologize. I am really tired and can't really think straight. I'm sure you've been there, so no complaints. Let's just move on. Page 570. All right, so perimeter and area of similar figures. I really don't like the way that this is explained, so I'm going to skip it, and I'm simply going to say that this is the key part right here. Let's try the highlighter. In similar figures, okay, the perimeters are related by the scale factor K. So underline that or something. Area, okay, scale factor, area is K factor squared, or X scale factor squared. So Area of the other similar figures is k squared. Perimeter is k. Perimeter equals k. So whatever I'm not saying the value of the perimeter, I'm saying the change in the perimeter. So if the figure is decreasing by a half, a scale factor of a half, as you saw on the previous page, that means the perimeter should also be decreasing by a half. Scale factor is a half, perimeter decreases by a half. And we'll get to it. In fact, I'll skip it for now. We'll talk about area later because I really don't want to overload you right now. So let's look at examples of when the perimeter changes. So right now we're looking at, whoops, sorry about that. Erase that. We're talking about perimeter. Okay. Two rectangles are similar. One has a length of 6 inches and a perimeter of 24. The other has a length of 7 inches. What is the perimeter of this rectangle? So for all intents and purposes, the first rectangle mentioned is going to be the original. The second is going to be the dilation. So here's the first, length of 6. Here's the second, length of 7. So before we talked about dilation over original equals scale factor, right? We talked about it. K equals D over O, which means 7 over 6 is my scale factor. One has a length of 6, one has a length of 7. The dilation is the second one. Okay, so that means the scale factor is 7 over 6. Got it so far. It also gives you the perimeter of the original is 24 inches. Okay, the original, O for original. O is on the bottom. So there's a couple of different ways to look at this. We've been working a lot with proportions. So what I would say is kind of forget about all this. Let's set up a proportion. D over O equals D over O. So one of them is going to be scale factor. The other is going to be the actual perimeter. I'm going to do D over O equals D over O. Good news, if you had success with this on the quiz last week, this should be a piece of cake. Bad news, if you did not have success on last week's quiz, this might be a little challenging. So ask questions if you need to. I'm sure that Mr. Hernandez is going to be bouncing back and forth and will be able to assist. And again, if it is not vital that you have 100% mastery of this today. I want you to have a basic understanding, do a handful of problems correctly, so that over the next couple of days we can really get into some nuts and bolts. So let's take this 7 over 6 scale factor and use that as one of our relations that we're going to use for proportion. Okay, so original, where'd it go? I underlined it. Original is 24 inches. Okay, so that means 24 is going to go on the bottom. And I am going to be solving basically for this. I'm using the letter D just to keep it consistent with D meaning dilation. You can really use whatever letter you want. So again, there's a handful of different ways to do this. Of course, you can cross multiply. That will always work. I would strongly encourage you, though, to look for patterns first. And the reason that I encourage you to do that is because it really helps you develop your mental math skills and can get you there faster. Instead of having to multiply 24 times 7 and then divide that product by 6, it can really be a time saver, especially if you're taking a test like a PARCC or the MAP or whatever in the future. I just really believe in being able to do as much in your head as possible. And of course, but wait, Mr. Hanson, you make a sure work all the time. Well, yeah, I mean, because that's the ultimate goal, is for you to be able to do these kinds of calculations in your head. You should not need a calculator, in my opinion, unless it's for, super hard stuff. What does that mean? I don't know. It means whatever you want it to mean. So remember, we want to go toward the variable. So this is going toward the variable, 7 towards D, 6 is going toward 24, and it's being multiplied by 4. So my pattern here is from left to right times 4, which means if I multiply 7 times 4, I'm going to get my answer. 7 times 4 is 28. Notice the perimeter of the new rectangle is, ta-da, 28 inches. So I solved that using a proportion, much like I've been doing in the previous couple of lessons. All right. If you need to replay that, go ahead and pause the video now. Pause the video now and go back and look at that. Otherwise, we can venture ahead and do an example on your own. Problem A. Triangle LMN is similar to triangle PQR, so they are similar. I like to draw my thing there just in case to remind myself. So what does that mean? Let's backtrack to what similar means. Similar means all the angles are congruent, corresponding angles are congruent. So if it's LMN and PQR, that means angle L goes with angle P, angle M goes with angle Q, and angle N goes with angle R. It also means that the side lengths are proportional. If the perimeter of triangle LMN is 64 meters, what is the perimeter of triangle PQR? All right, so let's take a look at a couple of different things about this. So just like in previous lessons, unless otherwise specified, I'm going to treat the figure on the left as the original, and I'm going to treat the figure on the right as the dilation. Okay. So what is going to end up happening here is they're giving me information about triangle LMN. They're telling me that this perimeter is 64 over here, and this perimeter is what they're asking me to find. So if I consider D over O equals D over O, dilation over original equals dilation over original, then here's what I would come up with. Again, I have, when I'm looking at proportions, 1, 2, 3, 4, 4 spots. They give me 3 pieces of information. I'm trying to find the 4th. So in this situation, I'm going to have the dilation. I'm going to use side length over the side length equals the perimeter over the perimeter, or I can do perimeter over perimeter equals side length over side length. It really makes no difference. So just for the sake of keeping things simple, I believe over here we ended up putting the perimeter on the bottom. So let's go ahead and put the perimeter on the bottom for both of these. So what I'm going to have is the dilation is going on top. So I have the side length of 18, which corresponds to the side length on the original of 24. Remember, it's D over O. And that's going to be equivalent to the perimeters. So the perimeter of the dilation is what I'm trying to find. So again, that is going to be your variable or whatever. So I'm going to use D just for the sake of argument. The perimeter of the original was the 64 meters. That's going to go on the bottom. Okay. Now, issue here is there is not necessarily a pattern to get you from 24 to 64. So this is certainly a situation where I'm going to have to cross multiply. So I'm going to go ahead and multiply 18 times 64 and 24 times D. So that'll give me this. I'm just going to move it over here because I kind of ran out of room to the bottom. I'm going to have 18 times 64 equals 24 times D. I'm going to go ahead and solve from there. So you end up with 18 times 64 equals 1152, and 1152 equals 24D. If you divide both sides by 24, you get an answer of 48 meters. Okay, 48 meters. Hopefully that makes sense to you. So 18 over 24 equals 48 over 64. Those are equivalent. That is the perimeter of triangle PQR. If you have questions or you're not sure about that, please go back and take another look. Otherwise, we're going to forge ahead. Okay, next example. Remember, scale factor, it comes from the idea of like model cars, model planes, blueprints compared to buildings, things like that. So keep that in mind. Here we go. In a scale drawing, the perimeter of the garden, I think it should say a garden, but you get the idea, is 64 inches. The perimeter of the garden is 64 inches. The actual length of side AB, which is this right here, is 18 feet. What is the perimeter of the actual garden? Okay, so it's giving me steps on this page to kind of walk through how to do this. Now, if you looked closely, you saw that the actual distance is 18 feet. Let me highlight that for you because this is where it's going to start to get a little bit fishy. So 18 feet versus the side length on the blueprint is in inches. So that's one issue that we have to tackle, is the conversion from feet to inches or vice versa. So step 1 tells us the actual length is proportional to the length in the drawing with a ratio of 18 actual feet is equivalent to 24 inches. So again, like you got to kind of think outside the box a little bit here. We talked in terms of dilation and original. So the book doesn't really use that terminology. In my opinion, this should be flip-flopped, but you get the idea, okay? The original, I'm assuming that, oh, I'm sorry, no, it does make sense because the original would be the blueprint. Generally, people make a blueprint before they build something. So the blueprint is the original, and the building, in this case the garden, after it is built, would be the dilation because you have it on paper first, and then you're actually constructing it. So this does make sense. I've got 18 over 24. 18 feet is the dilation over 24 inches, which is the original. So it does still play true to what we were doing. I'm going to use lowercase letters because my D's and O's were looking kind of the same on the other side. It really doesn't matter if you're using capitals or lowercase. I'll just do it because I'm writing with a mouse. So at any rate, this does work. The only issue though is I have to make sure that I'm talking in terms of the same units. So I either need to change them both to feet or I need to change them both to inches. And the issue here is 9 over 1, 24 inches. If I divide, Okay, so I'm going to essentially, well, you'll see that it doesn't matter because a foot is 12 inches, right? So if I change the bottom to feet by dividing by 12, I would have 18 over 2. And 18 over 2 would give me 9. So you can see that the book changes 18 to 216 inches, 216 inches from 18 feet by multiplying by 12. So from that standpoint, to find scale factor, it really makes no difference if you're using inches or feet, okay? So again, if I divided the bottom by 12, changing inches to feet, that would be 2 feet. 18 over 2 is the same as 9 over 1 here. So it makes no difference which units you change it to, as long as the units are the same on the top and on the bottom. Alright, so now after that, it's asking me to find the perimeter of the garden. So, and you'll notice that they give the answer in 2 different dimensions. They give the answer, they give the answer in inches or in feet. So, generally speaking, feet would make more sense for the size of the actual garden. So I would argue, if I go back to this part, that it would make a little bit more sense based on the fact that what is the perimeter of the actual garden? Okay, well, 576 inches, I really don't know what that looks like or have an idea of what that is. It's not a reasonable amount of inches for me to kind of understand what it looks like, whereas 48 feet might make a little bit more sense to me. So generally speaking, I want to use the unit that is most appropriate, and in this case, I think feet is the most appropriate for the actual garden. So I'm going to go back here and say that rather than this being the 216 over 24, I think it should be 18 over 2. Changing inches to 2 feet doesn't change the scale factor at all. The scale factor is still 9 over 1 because 18 divided by 2 is 9. And I'm going to be better set up to have my answer with the correct units, or with the most appropriate units, I guess I should say. So, at any rate, find the perimeter of the actual garden. So if the scale factor is 9, what they're doing simply is, that means that if the scale factor is 9, remember, I can just multiply 9 times the perimeter. Or, if it makes you feel better, here's what I could do. I could have 24 inches as the side length here, okay? That's giving me the scale factor, which I'm multiplying by the perimeter of the the original, I'm sorry, because the blueprint is the original, to find the perimeter of the dilation. So, any way you look at it, you get 48 feet, okay, or 576 inches. In my opinion, 48 feet is a more reasonable answer, okay. Mr. Hanson, I'm confused. Okay, no problem. So let's backtrack. The perimeter of the garden is 64 inches. Okay, now the issue here is, changing the perimeter also to feet. 64 isn't divisible by 12, unfortunately. So here's my issue if I do feet. Basically what I have is, again, dilation over original. It's giving me the perimeter is 64 inches for this triangle on the blueprint. So again, without being incredibly confusing, if I divide 64 by 12, okay, 12 goes in evenly, which is 5 times. That makes 60. So I have 5 remainder 4. Well, 4 out of 12 is a third. It's 5 and 1/3. That's the perimeter in feet of this blueprint, 5 and a third. Okay, and if I multiply this by 9, 3 times 5 is 15, plus 1 is 16. So I got 16 over 3. That's the improper fraction form of this mixed number right here, times my scale factor, times 9. Okay, and when I'm multiplying fractions, I'm going to put my whole number over my denominator of 1. We've talked, I think, a few times before about cross division, cross canceling. So 9 and 3 have a common factor of 3. So I get a 3 and a 1. 9 divided by 3 is 3. 3 divided by 3 is 1. And I multiply across the top and I multiply across the bottom. 16 times 3 is 48. Excuse me. 1 times 1 is 1. And 48 over 1 is obviously 48. So that is where this is coming from. There's my 48 feet for the perimeter of the building, if that makes sense, the actual garden. Okay. Again, if that was confusing, back it up, take another look at it. I threw a lot of numbers at you, so at the end of the day, it just makes what makes sense, or what needs to make sense, is that both of these units are the same. I can't have feet and inches. They either need to be feet or inches and inches. And it makes no difference which, based on scale factor. Okay. So again, if you need to see that again, go ahead and do it again. I'm going to encourage you to do this with example B, because this is we're going to actually stop after 2B and just focus on perimeter for today. So what I would really like you to do is pause the video, do as much as you can on your own, and then when you're ready to check, or if you get stuck, then play the video and see if you can match your answer to mine. Alright, so the scale factor is the most important piece of information, and it does involve a little bit of legwork as well. So 2 quilting squares are shown. The scale factor is 3:2, which means this is clearly bigger than this one. You can tell by looking at it by a scale factor of 3:2. In other words, this area, or the dimensions are 1.5 times as big as this one. So how do I navigate that? Well, first of all, they're squares, all right, which means that all the sides are the same length. Don't forget that. Squares, all the sides are the same length, which means if this side here is 4 inches, then that's 4, and that's 4, and that's 4. So if I want the perimeter, it doesn't tell me what the perimeter is. I can calculate the perimeter of this based on that perimeter P equals 4S, or just adding the 4 sides together. So perimeter equals 4 times 1 of the side lengths. The side length is 4, so 4 times 4 is 16. That's where I'm getting this number over here. This is simply the scale factor. I'm going to use the scale factor as a fraction, as one side of my proportion, and I'm going to fill in the values on the other side. So 3:2 means, again, this is the 3 and this is the 2. So this thing is 3/2 bigger than this, or I'm sorry, the side length. This side length is 3/2 bigger than this. And I know this perimeter. I don't know anything about this square. I don't know a side length, and I don't know what the perimeter is. In fact, that's what it's asking me to find. What is the perimeter of this big square? So with my information, I can fill in 3 of the 4 pieces and then calculate the 4th one. There is nothing wrong with cross-multiplying and solving. That would give me 2D equals 48. And then if I divide both sides by 2, it's the same as looking for a pattern. My pattern this way is times 8, which means I would have to multiply the top by 8, and that would give me 24 inches. 24 inches is the perimeter of this big square. Now, if I want to step further, and I think it's worth showing you this because it can show you where the scale factor came from. Let's say it was also asking you for one of the side lengths of a square. Well, I'm simply going to use this perimeter formula and work backwards. So if my perimeter is 24, which I just calculated, I'm going to have 24 equals 4s, and that's a one-step algebra problem. I'm going to divide both sides by 4, and I'm going to get s equals 6, which means 6 inches. Each side length is 6, and why is that important? Okay, it's important to show you then what the scale factor is, because these squares are similar. Any squares that are not the same size are similar because they're both the same shape, right? This is a square, this is a square. This is the dilation, d over o, right? d over o. In this case, I'm going to compare the side lengths. Well, the side length is 6. This side length is 4. And if I simplify that, what happens? I get 3 over 2. Wasn't that the scale factor? Yes, it was. So that's why it's significant. I know that I did that correctly if I can simplify the relationship of the side lengths and get the scale factor for k. All right. So this is a good stopping point. If you need to see this problem again, obviously go back and take a second look. We are not going to venture forward to area today. We'll worry about that when I get back. This is a really, really good introduction, and clearly it was, a bit long. We're going on, 40 minutes here almost, which is good. It's good to have that solid foundation built for perimeter before we go on and do anything else. And there's some pretty abstract problems here. So here's what I would say. Again, pause the video now, go back and look at problem B again if you need to, and join me here in a minute. Okay, so here's what we'll do with your time remaining. I know that I left sub-plans saying that you should have page 573 for homework. So obviously, because we didn't get all the way through the lesson, I'm not going to make you do the whole page. It also mentions one of the IXL skills, but I think we're going to kind of pass on that for today. Well, maybe we'll come back to it at the end. Here's what I would like you to do right now. Page 573. You can do questions 1, 2, and 3. You can do questions 1, 2, and 3. I would recommend, looking back in your packet, questions 1 and 2 are going to look like example 1, I believe. And then question 3 should look like the last example we did with the blueprint. All right, so you should be able to do those on your own. And in fact, I would like you to try these independently and work as quietly as possible with the idea that you're going to compare answers at your table when you're done with those 3 problems. So let's go ahead and do that. It's going to leave you with a little bit of time left that you can visit IXL skill. Let me take a look at which skill it was. It's F9 in algebra. So if I take a look at IXL here real quick, you go to your IXL situation and look at algebra 1 tab, A1, F9, and you can get a little bit of a start on here. I'm hoping that area and perimeter. Okay, so the issue is, unfortunately, so yeah, they give me an area problem right away. So unfortunately, not feeling ready yet. These can help solve proportions. Okay, so here's the bummer about this. If you get an area problem, you kind of got to skip it for right now. So I'm just going to put in a 0 and submit. And whatever, dude, for right now. The figures below are similar. What is the perimeter? Okay, so I would play around with some of these perimeter questions. Make sure it's a perimeter question, and make sure that I'm really not worried about your SMART score on this right now. So just make sure that you're working on perimeter questions when you finish questions 1, 2, 3 on page 573. All right. Hope you all have a great day. I hope you found this lesson helpful. Please rewind at any point and review anything you need before moving on. And I will see you all tomorrow, and hopefully I'll be able to share some of the great things that I learned at this IXL conference. All right? Have a great day.